Good morning, everyone. Today we are going to present our CSE 106 mini project titled Empirical Analysis and Graph Simulation. This project was done by me, Onik Shah, and my teammate Syed Sariful Islam under the Department of CSE at East West University. Abstract. Our project focused on two main problems. First, we studied the time complexity of binary search through experimental analysis. Second, we simulated a social media followership network using directed graphs. The idea was to compare theoretical expectations with actual experimental results and see how closely they match. Introduction. The purpose of the project was to connect theory with practice. We had two key goals. One, validate the theoretical complexity of binary search by measuring actual execution times. Two, observe properties of social networks through graph simulation such as connectivity and structure. In short, we wanted to bridge the gap between classroom concept and real world application. Methodology. Our work was divided into two parts. For binary search, we implemented in Python and tested it on array ranging from 10,000 to 50,000 elements. Each case was repeated 1,000 times to get reliable average. For the followership graph, we simulated network of 5,000 to 25,000 users. We randomly generated directed hits and then computed metrics like in degree out, degree and strongly connected components. Results. Binary search our experiment confirmed that execution time grow very slowly and complement to input size. This match the expected logarithmic behavior of log. Although there were minor differences from the theoretical model, those come from system overhead and constant factors, not the algorithm itself. Graph simulation. In the graph simulation, we observe that as the number of users increase, the number of strongly connected components decrease. In other words, the graphs become more interconnected. We also notice the formation of a large connected subgraph, which is similar to how real social media networks to evolve. Discussion. From binary search, we learned that experimental results strongly support theoretical predictions. From graph simulation, we confirmed that the sum of in degrees equal the sum of out degrees as expected. Also, larger network tended to improve connectivity, showing patterns similar to real-world social platforms like Twitter or Instagram. Conclusion. To conclude, our project successfully demonstrated two things. One, binary search indeed has logarithmic time complexity both in theory and practice. Two, graph simulation can model social networks, helping us understand how connectivity emerges in large systems. Overall, the project gave us deeper insight into how theoretical computer science concepts are reflected in real world scenarios. References. Finally, we would like to acknowledge our references, including the textbook Introduction to Algorithm by Corman et al., Introduction to Graph Theory by West, and of course the project guidelines provided in our course. Thank you for listening. We are happy to answer any question.